Namaste, everyone. Welcome to my presentations. I am Madhav Sanjel and I am a student in STEM education at Kathmandu University School of Education. Today, I am going to present my resource material development assignment on 3D atomic structure model and mini modern mini modern periodic table. This instructional materials was developed to make our learning of atomic structure more practical, interactive, and meaningful for grade 10 students. Introduction of these topics. During my 15 years of teaching chemistry or teaching school science, I found that many students have difficulty understanding of atomic structure and chemistry. They often struggle for identify proton, neutrons, electrons, atomic numbers, and electronic configuration of an atoms because these concepts are abstract for students. To solve this problem, I combine digital learning with hands-on activities. First, students explore the concepts through the PhET simulations. Then, by constructed a three-dimensional atomic model using locally available materials. Finally, they prepare a mini modern periodic table and learn through the game-based activities. And it makes the learning more fun and joyful. Objectives of this learning are these teaching methods. The main objectives of these instructional materials are the teaching materials were help to students to understand the structure of an atom, identify subatomic particles, construct a three-dimensional atomic model, prepare a mini modern periodic table, and develop a creativity, collaboration, communication, and critical thinking skills throughout the educations. Then educational foundations or educational theories related to the instructional models are related to this are connected to this are these instructional material or these materials are teaching strategies uh, based on the several educational theories. First, constructivism theories. Then this constructivism theory explains that students construct knowledge through the active learning experiences. Then second one is the social constructivism. Social constructivism emphasizes the learning through the discussions and teamwork. Then third, experiential learning. Experiential learning, experiential learning, and next one is the social constructivism. This emphasizes the learning through the discussions and the teamwork. Then experiential learning encourage or helps to students to learn by doing and practical activities. Then next one is the philosophy of pragmatism. Pragmatism supports the learning through the real life experiences. Then in addition, the lesson integrates the inquiry based learning, game based learning, and STEAM education to create a meaningful learning experience. STEAM integrations. This activity naturally integrates all five components of STEMs, that is science, technology, engineering, arts, mathematics, and all integrating to each others. Science helps to students understand the atomic structures. That means proton, neutron, electrons, and etc. are related to the science, and with science means the inquiry helps to learn the inquiry-based learning. Then technology is used through the PhET interactive simulations, that is technology. Engineering is applied while designing and constructing the atomic model by using the local materials. Arts are included through the creative designs and colorful presentation of learning materials. Then mathematics is applied while calculating the atomic numbers, proton numbers, electrons, mass numbers, and electronic configurations of these s- atoms or elements, and arranging the first 20 elements in the periodic table is the related to the mathematics. This integration makes the learning more enjoyable and interdisciplinary learning outcomes. Learning outcomes of these instructional methods are at the end of these lessons. Students are able to explain atomic structure, identify protons, neutrons, electrons, determine the atomic number and electronic configurations, construct the three-dimensional atomic models, and prepare a mini modern periodic tables which contains only 20 elements that is related to the students learning at schools. What learning materials are used in this instructional methods? The instructional materials were developed using the both digital technology and low cost, no cost, locally available resources. Digital materials included the PhET interactive simulations, laptop for the PhET simulations, and the multimedia projects for the di- showing on the boards or in the smart boards used as a digital materials. For the physical models, students used the cardboard, peas, rice grains, beans, maize, foam boards for the small mini atomic structure board, scissors, and the marker pens. These are used as a materials. Methodology. What methodology is used during the instruction models? Then the first students explore the fate simulations to understand the atomic structures. Then second, they discuss their observations in groups and discuss to each others. Then third, they construct three-dimensional atomic model or atomic structures. Then fourth, they prepared a mini modern periodic tables using the local materials, black forms, and etc. Then fifth, they participated in game-based learning activities to identify the elements, atomic numbers, groups, and periods. Finally, each group presented their work and reflected on their learning experiences. Results or learning outcomes or findings of these experiments are the classroom implementation produced very positive results. I found that students actively participate in every activity and showed greater interest in learning chemistry. Students actively participate in every active and showed greater interest in the learning chemistry. The PhET simulation helped students understand abstract concepts before constructing the models. Students successfully prepared attractive atomic models and periodic tables using locally available no cost and low cost materials. These activities improved collaborations, creativity, communications, motivations, and conceptual understanding. Reflections. The instructions material also improved my professional teaching practices. I realized and I feel that students understand abstract scientific concepts much better when they first explore them digitally and then apply their knowledge through the practical activities. The experiences strengthen my beliefs that learners centered inquiry based and STEM integrated teaching creates the deeper understanding and develops the important 21st century skills. At conclusion, the combination of these PhET interactive simulation, three-dimensional atomic models, and mini modern periodic table made the learning more interactive, meaningful, and enjoyable. The instructional materials enhance the students' conceptual understanding, creativity, collaboration, communications, and practical skills while promoting the active participations in the classroom. I believe that low cost materials, low cost, locally available materials can significantly improve these science educations and make learning more engaging for every students. Thank you very much for. Okay, now we have evidence that is related to the PhET simulations and progressive forms. Now let's see the video related to this evidence PhET simulations. This is the YouTube video. You can see and you can search the video Madhav Sanjil teach innovative for bright futures. You can observe this. I am unable to play this video in these presentations and due to the short time. Then next is the improvement of the periodic tables, then that is the mini modern periodic tables. Then after next is the uh, atomic structures constructed by the students during the teachings and learnings. Then after that, uh, these are the steps of learning. Now, first students construct these models. Then, after construct the mini atomic periodic tables. Then it helps to understand the learning concepts in progressively or sequentially. And after that, students learn that are the references that uses for me in my um, presentations or in my the sources. Thank you very much. Thank you for this uh, for this time.